Hi everyone, welcome to my YouTube channel. Today my discussion topic is model evaluations and explain the false positive and false negative with the Shapley and the lines. And in previous video, you see we do the feature engineering, feature selections, then the hyperparameter tuning, then select the base model. And in this video, we select the base model as a logistic regression. So you can see here in my screen, which we select the logistic regression and we train two models here, one with logistic regression without pipeline and then model two with pipeline. And these are the hyperparameter we go through the hyperparameter tuning, and these are the pipelines, and in pipeline we have TF, IDF, and then we have the same logistic regression with similar model. And now we train both of the models, and after that we will evaluate the performance of both models on the multiple metrics to make sure like the both model like behaving similar ways, like the prediction, like their accuracy, their precision, recall, like score, both would be the same. So before proceed further, I will move to the evaluation metrics best practices to improve the accuracy of our models, to fix the false positive, false negatives. There is some best practices. I will discuss those first. So here are the best practices to improve the accuracy in text classification. As we are also working in the text classification in this problem, like we have the review data in the text format. And so let me proceed with the first one is prepare a list of mandatory terms to fix the false positive. Like we can prepare a list of mandatory terms with respect to the positive class. For example, in this our sentiment analysis case study, like the positive features, like the mandatory positives, like the great, good, awesome, this kind of positive features, and we can prepare a list, and to make sure like the no data point without one of these mandatory list is classified into it, means like the all positive predictions, like all predictions classify as a positive should be should include the mandatory terms, at least one mandatory terms. And in this way we can avoid the false positives. Like first our model is generate the prediction, then after the prediction we check in our list, like our list, then we compare the row review with the list, like at least one mandatory terms is including this review or not. Based on this we can do the removing of the false positive or fixing of the false positive. But here we need to take care one things, like make sure all possible cases must be included while making this kind of list, like that there is possibility of the multiple number of the mandatory terms or features, so we can include those kind of features while creating this kind of list. Second was one is the unintended bias due to the class imbalance. So it's happened like due to the class imbalance, our particular features or word can bias toward particular categories due to the class imbalance. So how we can fix this? We can fix by adding the new synthetic data with the imbalanced features. We can create multiple data points with imbalanced terms or features, and then mark those data point to the minority class. And in this way, we fix this imbalance problem, and we fix this unintended bias through our data. And next one is human in the loop by using the probability thresholding. So as we see generally, if we found the false positive, false negative, then there the probability range is low probability. And then we set a probability threshold. If our probability value, like the prediction probability value is less than the threshold, then we send those prediction for the human reviews, like human in the loop techniques. And then human can handle this kind of false positive, false negative in critical scenario. For example, the medical, like the diagnosis of any diseases, we can use this kind of techniques. And we can also use the model stacking, like the false positive from the one model, then we send those data to the another complex model, and then another complex model create on the prediction or generate the prediction for particular model. But here is the, like by using the probability thresholding, we filter out the low probability predictions and then send those for the reviews. And another one is like the again prepare a mandatory word list for the negative class to fix the false negatives. Similar to the false positive, we can prepare another list of the word to make sure the no false negatives. And here, like the in fifth point, we have like we can prepare a excluding word list by using the trigram, bigrams, and foregrams. During our VDA, we can find this kind of information. For example, good is relevant word for the positive class. If we see the good in any sentence, in our case sentiment analyzer, then we see okay, good is an important feature. But when it appear with the note, then good is not relevant for the positive class. So in this way, like if like the good is coming with the note, then we can penalize the good or we can exclude the good. So this way we can fix the false positive and false negative. So let me back to the Jupyter here. So here I'm evaluating our models on multiple metrics. Here I'm using the 5 metrics: precision, recall, AUC, ROC score, F1 scores, and accuracy. And you can see here, like we receive the good F1 score here. If you can see here, like the logistic regression without pipeline and also with pipeline. You can see here in during the hyperparameter tuning and all we achieve 0.83, but here we increase features from the 5,000 to 10,000 now in this pipeline and this model training. So now we achieve 0.89, and you can see overall scores like the precision scores also good, recall score also good, like 0.89, 0.89, ROC score also 90.6, 0.96. F1 score also good, 0.89, accuracy also 0.89, and same happening for the logistic regression with pipeline. So that's the key findings, and it's the recommended in case of evaluation, we can use multiple metrics. And let's see what kind of like the now we have the accuracy is 80.9, but still we have the like the around the 11% mistakes. So as we see here, like accuracy scale is 0.89, so still there is a possibility of the 0.11 mistakes. So let's see what kind of mistakes we have through the confusion matrix. Confusion matrix, we are basically plotting the true positives and true negatives, then false positive, false negative. These are the like the predicted one and actual one. These are the true positive, and these are the actual zero and predicted zero means true negative, and these are the false negative, like actually this point belong to the positive class, but they are predicted as a negative class. And these are the false positive, these point belong to the negative class but predicted as a positive class. So this is a very nice visualization with the help of confusion matrix. Let's analyze why this is coming into the false positive, why this is coming into the false negative. Let's analyze the feature contributions and the impact of features while generating these kind of predictions. So here basically we create one custom test to store or to analyze our false positive and false negative data. And in red color, we have the false positive data here. Like these are belong to the false positive. This is the number of the data points, like the index of the data point. Then we have the data point here, like the review overall, and then we have the rating. And you can see here, like this rating is marked as a positive class, like the positive, but there, if we compare with the rating provided by the user, like the rating range is 2. So let's see what kind of challenge here. And now in the scroll, if we scroll down, in the green color, we have the false negative, and you can see here like this is the again the index, this is the row review, and this is the rating. You can see here like the rating is 9, and still like our model is marking this as a negative class. That's why it's false, not negative. Let's move further. So here is the explainable AI is coming into the picture. So you can see here in my screen. So first I'm using the share, and in the share basically we are checking the marginal contribution of the features in prediction, in generation of the prediction. And here we are using the Shap explainer for the linear models, and we are calling here our logistic regression model. Then we have the features, and then we have the features names from our vectorizer, and then we are generating the Shapley value for our test vectorizer data, and then we are plotting those values. And you can see here, like we have two color here. One is the red color, second one is the blue color. Red color means contribution is high, and blue color means contribution is low. If our color is blue, then it's meaning its interpretation from the Shapley graph is the contribution of those feature is low. And if our color of the graph is red, then its contribution is high. And you can see here, like great is contributing toward the positive class. In this right direction, you can see here, these are the positive class contributions. This is the positive contribution, and these features have the contribution toward the negative. And you can see here, this is great contribution, contributing around, this is the like the whole contribution around the positive class. Then we have the bad one. So as a domain, we know like the if bad is negative word, then nothing, then worst. These are the negative words, and their contribution also like toward the negative class. There is the high contribution toward the negative class, and great is positive. So that's why the contribution also toward the positive class. And fun also positive word, and then the marginal contribution of the fun is also toward the positive class. And same in the waste is a negative word, that's why contribution also negative. Good and enjoy both are the positive words. If like the user mentioned, like I enjoy this particular movie, this is a good movie, so both are the positive, so that's why the contribution is toward the positive. And boring is a negative word, so that's why the contribution also negative. So you can see here, like we got the idea from here how the feature is contributing toward the positive and negative class. And as I explained you during the best practices also, like we can prepare the mandatory features list, mandatory terms list. So this from the Shap we can get those kind of lists, like the mandatory feature, important feature. Then we make our custom hacks to fix the fake failures and fix, sorry, false negative and false positive. Visualize the marginal contribution of the features. Here we choose one review from the false positive, and now we are first printing the probability score of those false positive value, and then we are checking the marginal contribution of the features. And you can see here the probability score is very less, it's 0.8. And if we apply the thresholding techniques like we discussed during our best practices, if we apply thresholding here, we can fix this false positive. And let's see the contribution of the features. And you can see here the contribution toward the positive is higher. And you can see here contribution of fun feature is 0.07, man is 0.19, then see recommended feature also 0.08, and most funny movie funny also 0.14. So that's the contribution of positive features is toward the positive. So that's why mark as a false positive. And this there is like that less contribution from these features. Like you can see sad contribution 0.1, 0.125. So that's why it's marking as a false positive, because contribution of positive feature is high. And let's read the row review. You can see the story, note, find, movie, funny, man, scenes, leaves, post, open, offense, other justified, basis, rand, DVD, skip, I load content review, see overall vote. Currently, other agree still remember since repack. Seeing think me fun group note feeling anyway humble viewed leaving many tea easily open note recommend anyone. You can see here the word note recommend anyone, like the reviewer is not recommended this particular movie to anyone. Sad thing you can see here, like the user is not liking this movie, but still this movie is marking as a positive sentiment and positive class. That's the false positive. And one way we can fix this one by using our thresholding techniques. Another way we can use here, let me see if we can use our, yeah, we can use our like the mandatory list also, and exclude word also, like where is the good coming but not but also note is coming. So that's why we can handle these things by using our exclude list also, as I did explain into doing our best practices. Now move to the next example. Next example also which was from the first PhD. And again we see the probability, and you can see here probability again low. And now in both cases our probability thresholding is work in both of the cases. And let's see the contribution of the features. Entertainment is positive, feature is contributing 0.193, this is his contribution. And sorry is contributing 0.18, this is the negative word. And let's see other word contribution different is 0.07, people thinks 0.14, thinks 0.11. Like these are the different features. You can see here, these are the different features, those are contributing toward the positives, and these are the different features which have a less contribution. These are the higher contribution, these are the less contribution, you can see here. And the higher contribution toward the positive, so that's why the class is marked as a false positive, and you can read here from the rules like this is the overall previous note like by the reviewer providing the negative review. So now let's move to the false negative and let's review the false negative. And you can we have select one false negative sample here. First, see the probability. You can see here the probability is again low, 0.42, and if we put the threshold of 0.1 from 0.5, and we consider like the low probability value in both direction, like the 0.6 to 0.4, then we can easily select our false negative. Our previous discussion false negative positive, and this one is the false negative. We can consider those all example, and we can fix in by thresholding also. And let's see the contribution. You can see here the OPOL is contributing more if you compare with the other one, like OPOL is contributing 1.0, and outstanding is contributing 1.4, drunk is 0.3, and well is 0. Let's see other features contribution. Entertainment 0.119, and revolutionary is 0.993. People know that watch movie, nothing bad, 0. Let's see, solo 0.7, driving 0.3, okay. Rate 0, note made 0.16. So you can see here, let's read the overview. Like watch movie, reading awful, viewer, little misunderstood people. You can see here, awful is used in this movie, but not for this movie. Not this is for the other viewer who provide the review for these movies. And you can see here like that this particular reviewer is like the movie is revolutionary innovative movie. It's liking the movie, innovative movie, not made for entertainment. So here is using the note made for entertainment, but the impact of this kind of feature like the note made for entertainment going toward the negative. So that's why this is also like the one reason, like the awful then note made for entertainment, this kind of feature is contributing toward the negative class. That's why it is going to the false negative. Create the solo purpose, punishing mankind, womankind, and so you can see overall is user providing the positive review, like the reason of the story of the movie is for the social cause. It's a good movie, but the awful word used by the reviewer for the other reviewer who providing the low rating and low bad reviews for this particular movie. Let's move to the line here. And previously we discussed the Shapley to explain the marginal contribution of features on the global level. So we consider the whole predictions, the whole data set, and then we use the Shapley explainer for the linear models. And here we use the LIME, and LIME basically consider the local data points. And it used the surrogate model like the easily explainable model for the decision tree, logistic regression, these kind of models, and then check the local, then use the local point to explain the feature impact on the prediction. So let's select our previous examples false negative case here, and you can see prediction class is 0, predicted class, and you can see here also like the actual class is 1 and is predicted class is 0. And you can see here like the here also you can see probability score is less as per thresholding. If we apply the thresholding here, we can tackle this one through the thresholding also. And let's visualize the impact of all features. You can see here like the 0 means negative class, so and 1 means positive class. And awful is contributing toward the 0 negative class, and drunk is contributing more toward the negative. So awful, drunk, driving, these kind of features is responsible to for this false negative. Read the whole review here. Watch movie, reading awful reviewers. So this awful note for the movie for the other viewers, and plot little misunderstand people. Movie revolutionary and innovative movie, a note mode for the entertainment solo purpose, punishing the mankind, womankind, outstanding joke. Government can utilize the movie for the betterment of society. So you can see here overall the positive things, but awful and drunk. These kind of negative words, solo, this kind of negative features contributing toward the more toward the negative class. So that's why this is marked as a false negative. So let's move to the another. Let's see the features exact score. You can see here the OPUL is contributing more if you compare with the whole features. You will see like the 0.23 contribution is OPUL alone. If you remove the OPUL, then this definitely this particular review is go into the positive categories. Let's do this. Let's do this experiment live. Okay, let me copy this review here and remove the OPUL from this review. Okay. Yeah, here we are using the input function to get the input in runtime. Okay, let me remove the OPUL here and see the impact of removing the OPUL. Yeah, here is the OPUL, and I'm using removing this one. Let's see. Okay, so now you see the impact here. We just remove one feature and you can see here, like this is marking as now is coming into the positive one, and the probability value is also changed 0.61. And you can see here now contribution like that drunk again contributing toward the native class, but other contributions outstanding entertainment, revolutionary movie, people who are contributing toward the positive class. So that's the way how we can fix the false positive, false negative, how we analyze our false negative, false positive, how we fix our accuracies, how we increase our accuracies in real time, how we dig down these things. And before removing any features, before adding any new features, we can utilize our domain knowledge also. And in real time in the industry, we sit with our domain experts, then we showcase these kind of visualizations by using the Shap, LIME or different techniques or custom techniques also. And then we showcase the false positive, false negative, why this accuracy is on certain level. Then on discussion with domain experts, we can remove these features. We can make the mandatory feature list. We can use the mandatory feature list to handle the false positive, false negative. And this is the way how we can fix our accuracy issues in the real time. So let me conclude this session. So in the starting of session, we do the evaluation of our models by using the multiple metrics. For example, the precision, recall, AUC, ROC, ROC score, accuracy metrics, F1 score. And then we see the few best practices to fix our accuracy issue by using the probability thresholding, human in the loop, mandatory feature list, and this kind of hack we can use. Then we move to the explanation of AI. We explain our predictions by using the Shap and LIME. Then we see the contribution, marginal contribution of each features toward the predictions by using the Shap on the global levels. We use the our logistic regression model and then linear explainer from the Shap, and then explain the predictions and contribution on the global levels with the help of Shap. Then we explain the feature impact on the local labels by using the LIME, and in the LIME we use the LIME explainer from the explainer surrogate models. So in case of like the math behind the LIME and Shap, I'm preparing the separate video. After this case study, I will share the video on the Shap and LIME, so that anyone have any issue regarding the Shap and LIME, you can directly coordinate with me also. You can put your comment here also. And I will put the few reference link regarding the blogs and all. You can refer to those blogs also in case of you have any doubt regarding the how LIME is work, how Shap is work. And so thank you for watching this video.